Hi people, welcome to the sixth part of our statistics series. In this video, we are going to discuss about some important statistical terms. Please watch my previous video to understand this video better. At first, we will discuss about variance. Variance measures how far a data set is spread out. It is mathematically defined as the average of squared differences from the mean. Variance and standard deviation are calculated in terms of population and samples. Population variance: when you have collected the data from every member of the population that you are interested in, you can get an exact value for population variance. The population variance formula looks like this, where sigma square is the population variance, sigma is the sum of all the differences, x is the each value, mu is the population mean, capital N is the number of values in the population. Finding the mean and subtracting the mean from each number in the data set and squaring the results. The results are squared to make the negatives positive. Otherwise, negative numbers would cancel out the positive in the next step, and it's the distance from the mean that's important, not positive or negative numbers. Averaging the squared differences. Sample variance: when you collect the data from a sample, the sample variance is used to make estimates or inferences about the population variance. The sample variance formula looks like this. S square is the sample variance, sigma is the sum of the differences, x is the each value, x bar is the sample mean, small n is the number of values in the sample. With the samples, we use n-1 in the formula because using n would give us biased estimate that consistently underestimates the variability. The sample variance would tend to be lower than the real variance of the population. Reducing the sample n to n-1 makes the variance artificially large, giving you an unbiased estimation of variability. It is better to overestimate rather than underestimate variability in samples. It's important to note that doing the same thing with standard deviation formula doesn't lead to completely unbiased estimate, since a square root isn't a linear operation like addition or subtraction. The unbiasedness of sample variance formula doesn't carry over the sample standard deviation formula. Now we will understand what is standard deviation. We will discuss about standard deviation to understand this much better. So the square root of variance is the standard deviation. While variance gives you a rough idea of the spread, the standard deviation is more concrete, giving you the exact distances from the mean. So in the above formulas of the variances, all we are doing is we are adding a square root to the formula. Example: if a die is rolled, then if we want to find the variance and the standard deviation of the possibilities, the solution is we find the possible outcome is 6. So the n becomes 6 and the data set would be 1, 2, 3, 4, 5, 6. To find the variance, firstly, we need to calculate the mean of the data set, which is 1 plus 2 plus 3 plus 4 plus 5 plus 6 whole divided by 6, which is 3.5. Now we can put the value to the data and the mean in the formula to get sigma square. Sigma square is 2.917 when we happen to calculate the standard deviation, which is square root of 2.917, which is 1.708. Similarly, I request you to all to try solving the below problem and mention the solution in the comment section below. Also, let me know if you guys need the solution. I'll paste it in the comments. So, find the standard deviation of average temperatures recorded over a 5-day period of the last winter. So, the data is given by 18, 22, 19, 25, 12. The mean is 19.2. Finally, we are going to discuss coefficient of variance. The coefficient of variance is a relative measure of variance that is always expressed as a percentage rather than in terms of units of the particular data. The coefficient of variation, denoted by the symbol CV, measures the scatter in the data relative to the mean. The coefficient of variance is equal to standard deviation divided by the mean multiplied by 100%. And a special note is that the coefficient of variation is very useful when comparing two or more sets of data that are measured in different units. So hope you all watching my videos, and I hope my videos are helping you to uplift your knowledge on statistics. Thank you all for watching. Like, comment and subscribe for more.